Hi class, welcome to another day and welcome to another lesson. We're on 2.7 today. We're graphing inequalities and absolute value functions. I believe you guys have graphed inequalities before in the past quite extensively. I'm not sure about absolute value functions. We'll go over those as well. Maybe you've been introduced to those before, but maybe not. So let's go through both of these parts of this lesson. The first one is graphing inequalities. Now remember, we have to change the direction of our sign whenever we multiply or divide by a negative. So that's going to be in this first one. When we multiply or divide by a negative. So we always got to make sure that we're recognizing if we divide by a negative, let's make sure we switch that inequality. Same thing as if we multiply. Now with inequalities, we do a lot of shading. Remember, we have a line like this, and then if it's in y equals mx plus b form, we would shade above the line, so like this, if it is greater than or equal to. Either of those two signs, you would shade above the line. Remember, only if it's in y equals mx plus b form. If it's in standard form or slope or point slope form, change it to slope intercept form so you can use this easy way of shading. In the same way, if it's less than or equal to, then you would shade below the line. So if you get a line that looks like this, and it's less than or equal to, you're going to shade below the line like this. Now, when we connect the dots, or when we make a line, we're going to use a dotted line whenever it is greater than or less than. And we're going to use a solid line like this if it is less than or equal to, or greater than or equal to. So we got to make sure there's a lot of things to focus on when we graph these lines. The shading, the multiplying and dividing by a negative, the dotted or solid lines. Make sure you have a good grasp on that. If you don't understand that completely, be sure to ask me some questions with that. So let's go through some example problems. Let's graph the line 2x minus 3y is greater than or equal to 6. Well, the first thing we want to do, because it's easy for shading, is to change it into slope-intercept form, y equals mx plus b. So let's get y all by itself. We'll subtract 2x, so a negative 3y is greater than or equal to a negative 2x plus 6. So now that we have a negative 3y is on the left, we want to get y all by itself, so let's divide by a negative 3. This is where I'm talking about, class. Whenever you multiply or divide by a negative, you got to change the direction of the sign. So instead of y is greater than, you're now going to change this sign and say y is less than or equal to. Because we're dividing by that negative 3, you have to change the direction. So instead of greater than or equal to, it's less than or equal to. So now let's simplify this part. A negative 2 divided by a negative 3 is, those look like decimals now, a negative 2 divided by a negative 3 is a positive 2/3 x. And 6 divided by a negative 3 is a negative 2. So now we're going to graph this line. It's in y equals mx plus b form. The y-intercept is at a negative 2. And my slope is a rise of 2, run of 3. So now we're going to connect these 2 points. With any line, all you need is 2 points. So we ask ourselves the question, do we use a solid line to connect the dots, or do we use a dotted line? This right here, it's less than or equal to, tells us that we use a solid line. Whenever it's less than or equal to or greater than or equal to, we're going to use a solid line to connect those dots. So let's connect these with a solid line. Here we are. And there's our line. So now we also have to remember that we're going to have to shade. So when we shade, it's less than or equal to. So whenever it's less than or equal to, you shade below the line. So this is what I expect from you on your next chapter test. Again, hopefully that's all review. Hopefully it's just kind of bringing that back to your memory and practicing that. So we have 3 more problems. Why don't you guys pause the video, practice the next 3 problems on your own, and then unpause the video and see how you do as you compare with my answers. So here we have this one, x is greater than y. Another way of saying that is y is less than x. Now we have it more in our y equals mx plus b form. Our b is 0 because it's y is less than x plus 0. So our y-intercept is 0, and our slope is up 1 over 1 because our slope is an understood 1. So now less than says that we're going to connect these dots with a dotted line. So here is going to be our line. That's y is less than x. So if y is less than x, if it's less than, we shade everything below the line. So this is what our shading looks like for problem number 2. Let's now practice problem number 3. X plus 2 is greater than or equal to 0. Notice how there's no y variable. If there's no y variable, let's isolate x. So it means that x is greater than or equal to a negative 2, because I'm going to subtract 2 to get it onto the right side. So if x is greater than a negative 2, when we say that x equals a negative 2, that is a vertical line, is it not? So we're going to do the exact same thing. If it's greater than or equal to, it's going to be a vertical line at a negative 2. So here's a negative 2 right there. Let's draw a vertical line. Now let's be careful. Are we going to use a dotted line or are we going to use a solid line at negative 2? Because it is greater than or equal to, we're going to use a solid line. So draw a solid line that is vertical at a negative 2. So there we have it. And now we got to ask ourselves the question, do we graph above or below the line? When it's an x equals line, you no longer ask yourselves the question above or below, you're now asking right or left. We want everything greater than a negative 2. When we talk about the x-axis and greater than, we talk about everything to the right. Like, here's a negative 2, a negative 1 is bigger than a negative 2, 0 is bigger, 1 is bigger than a negative 2, 2 is bigger than a negative 2, so on and so forth. So you want to shade all of this area, which means you want to shade everything to the right. So hopefully you shaded all of this. That's what we get for problem number 3. Problem number 4 is maybe somewhat like it. Once again, you only have a y variable. You don't have two variables of x and y. So let's isolate y. To do this, I would say the easiest way would just be to add a y over onto this side. So now you have y plus 3 is greater than 4, and then you would subtract 3, and you would get y is greater than 1. If you brought the 4 over right away, now you would have, after you subtract 4, you would get a negative 1 is greater than a negative y. Well, now you would have to divide by this negative 1 in front of the y. So when you divide by a negative, you have to change the sign. So now y is greater than a negative 1 divided by a negative 1 is a positive 1. So y is greater than 1 or y is greater than 1. Either way, you get y is greater than 1. So when you have a y equals line or a y is greater than line, it's going to be a horizontal line. So let's go to 1, which is right here, and we're going to draw ourselves a horizontal line. With this horizontal line, it's going to be dotted, because it is greater than and not greater than or equal to. So we have that dotted line. And then we're going to shade everything above the line because it is greater than. So everything up here is going to be our shading. Hopefully that makes sense to you. Be sure to let me know if you have any questions on that when you get to class tomorrow. But I think you guys are all pretty good at that. This is just a refresher on things that you've learned in previous math classes. So now let's go on to maybe something a little bit new, and that's the absolute value function. The absolute value symbol on your calculator, I'll teach you how to do it once we take out our graphing calculators together, so everyone get out your graphing calculators, and we're going to graph this one. Graph the line y equals the absolute value of x. Now this isn't on your notes, so don't be trying to look through your pages and stuff like that to find this on your notes. Just pay attention with me, take your calculator out, let's go through this together. So on our calculator, we want to graph the line y equals the absolute value of x. So our y equals button is the very top left-hand button. Y equals the absolute value of x. So you're going to press right now math, which is the third button down on the first column. Math, go over one column to NUM. And then the first one, ABS, that stands for absolute value. Press enter right there. And I got absolute value bars, and hopefully you got that as well. So it's y equals the absolute value of x. So we put x in there. If we wanted to put x plus 2, well, now we could easily do that. If you wanted to go x, the absolute value of x, and then outside the absolute value plus 2, you would just press over and then plus 2. Okay, so hopefully that makes sense to everybody. We don't have that. We just have the absolute value of x. So now let's graph this guy. So we're going to press graph, which is the top right-hand button. Graph. As you can see, it is V-shaped. It is V-shaped. So if I were to look at the points here, like if I were to see where's this point at, where's this point at, where's this point, so on and so forth, I would go to second graph, which is my table. And now I can see, oh, when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. So on and so forth. I can do the same thing as I go negative. When x is a negative 1, y is a positive 1. When x is a negative 2, y is a positive 2. So on and so forth. So here is the type of graph that I see. I see that it starts at 0, 0. Okay? When x is 1, y is 1. When x is 2, y is 2. So on and so forth. And it goes up linearly like that. And now, instead of continuing to go down and to the left, it hits 0, 0 and it bounces up and goes up and to the left like that. Now, I'm going to tell you, class, every single absolute value graph is V-shaped. So you're going to get this hard point right here. It's called the vertex. Okay, you're going to get that on every single one of them. Along with that, on every single one of these problems, all of our slopes are going to be 1. So we're either going to go up 1 over 1 on every single one, or we're going to go down 1 over 1 on every single one of these graphs. So we're never going to have a slope that's bigger or less than 1. It's always going to be equal to 1, which means you're going to go up 1 over 1. So with that, you guys put in your calculator these next 6 problems, and I want you to put them in, draw them on our note paper, and then check your work with mine after you're done. So please pause the video at this time. Well, here's what you should have got for this first one. Y equals the negative absolute value of x, so it's still going to start at 0, 0. And now this negative sign, instead of going up 1 over 1, so on and so forth, that negative sign makes it go down. So it's down 1 over 1, down 1 over 1, so on and so forth. You get a line that looks like this, and you get the other line that looks like that. It's always going to be V-shaped. I guess that's an upside-down V, but it's always going to have a vertex, this time opening down. So now let's see, when it's our absolute value signs, we graph it just like it is y equals the absolute value of x, except now we have to pay attention to shading. So it's greater than or equal to, which means that we're going to use a solid line here instead of a dotted line. And then if it's greater than or equal to or greater than, you shade everything above the vertex. If it's less than or equal to, you shade everything below the vertex. So if it's greater than or equal to, let's shade everything above the vertex. So it's everything right in here. There's our problem letter B. Problem letter C, when we have a +2 on the outside, all that happened is our graph shifted up 2 units. Our y equals the absolute value of x was right here. So now, when it's +2, it just went up 2 units. Hopefully you guys can all see that. So now let's pay attention to this. Once again, our slope is 1, so it's up 1 over 1, up 1 over 1, up 1 over 1, so on and so forth. I told you that it's always going to be like that. It's greater than, so that means it's going to be a dotted line. And it is greater than, so as far as our shading is concerned, once again, we shade everything above the vertex. So everything right in there. And that's what you should have got for problem letter C. Problem letter D, this time, we have a negative sign in front of the absolute value, so that's going to make the graph open down. And we also have a -1 on the outside of the absolute value. We learned on last problem, when it's inside the absolute value, it shifts it up and down. Notice what happened on this one, which stink bomb, I did wrong. No, I'm sorry. I did that right. I apologize for that, class. When it is a -1 here on the outside, it shifts it up and down, so it shifted it down 1 unit. And then this negative sign says that it's going to open down. So down 1 over 1, it's going to be a solid line because it's less than or equal to. And now we got to talk about the shading. When it's less than or equal to, you shade everything below the vertex. So here is where you should shade for problem letter D. 2 problems left, problem letter E. This time, this 3 right here is going to shift my graph up 3 units, and then this 1 shifts my graph left and right. So as you can see, even though it's x minus 1, this part will always be opposite of that negative 1. So usually when you think of negative 1, you think of left 1, but now it's going to be right 1 up 3. That's where your vertex is going to be. You know it's going to open up because this is a positive number. There's no negative right there. And then you know that it's going to be a solid line that connects it because it is less than or equal to. So that equal part makes it a solid line. And if it's less than or equal to, we're going to shade everything below the vertex. So we're going to shade everything in here. And that's what we should get for problem letter E. And then finally, problem letter F. This 2 says I'm going to shift it down 2 units. This positive 1 says I'm going to shift it left and right, and because it's positive, I do the opposite, which is left 1. So this part says down 2, left 1. It's going to open down because that's negative. So down 2, left 1. There's my vertex. It opens down, and it's going to be down 1 over 1, down 1 over 1, down 1 over 1, so on and so forth. We're going to connect all these dots with a dotted line because it's greater than and not greater than or equal to. So that's why we get all these dotted lines when I connect them. And then we have to talk about shading. It's greater than, so when it's greater than, I shade everything above the vertex. So I get this. So, as we summarize, there's a couple things that we can talk about on our next chapter test. When you see graphing absolute value, you could always put them into your calculator, and I would have no problem with that. If you want to do these problems quickly and efficiently, you can just follow these simple rules. Whenever it's in this form, okay, y equals the absolute value of x, and then when you have a number added on here, we call that a, and a number added on here, we call that b. A is what we found moves the graph left and right. Left or right. And remember, this is always the opposite part. If you saw x minus 3, that minus sign says you move it to the right 3. If it was y or x plus 7, that x plus 7 says that you would move it to the left 7 units. So you kind of got to think of opposite for the letter A. Letter B, you do what's written, and this time it moves it up or down. So if this part was plus 3, you'd move it up 3. If it was minus 4 on the outside of the absolute value, you would shift your graph down 4. So that's an important part to remember. And then this last bullet point, a negative sign in front of the absolute value sign makes the graph open down. So if it's positive, you're going to get a V. If it's negative, you're going to get an upside down V. So those things are also very important to remember as you do these problems. And remember, for our class, whenever I give you a problem, the slope is always going to be 1. So you're always going to go up 1 over 1, up 1 over 1, up 1 over 1, or negative 1, which is down 1 over 1, down 1 over 1, down 1 over 1, so on and so forth. So those things should be able to get you through this lesson. If you need more repetition with some of this stuff, if you need to ask me some questions, by all means, please come to my desk tomorrow and ask me as many questions as you need.